Hey, happy people. This is Mr. Wilcox. This is for pre-calculus. We're in our first chapter and we're going to review how to write equations of line state and slope-intercept form. And we're going to learn a new form, which is point-slope form, which you might have talked about a little bit in Algebra 1, but will come more important as you work throughout calculus. So first of all, slope-intercept form is y equals mx plus b. Remember, m is the ratio of the change to you in your vertical direction to change in your horizontal direction, or change in y over change in x. So that's your slope. And b is the y-intercept, so the point where your line touches the y-axis. So for no matter what piece of information they give us, we need to make sure we know the slope. We know to find our b, we might have to plug in a point to find our y-intercept, and then we're going to write our equation. So I have a few examples of writing equations of line and slope-intercept form, and then we'll talk about point-slope form. So slope-intercept form, our first example, write an equation slope-intercept for the line that has slope of -3/4 and a y-intercept of 7. So remember, our slope is our m, so they give us our m right away. And our y-intercept, remember that represents the point 0, 7. So they tell us what our b is right away. So into y equals mx plus b, I'm going to plug these things in. So I'm going to get y equals -3/4 x plus 7. So that one gives us exactly what we need right away, so we can write our equation. All right, next example. They give us a slope and a line and a point the line passes through, so a slope of 2. And we know our line passes through -3, 2. So we know our slope goes up 2 over 1, so our slope is 2. And every point we're ever given, remember, gives you an x-coordinate and a y-coordinate. So into y equals mx plus b, I'm going to plug in what I know. I know that when y is 2, my slope is 2, and my x is -3. Now I can solve for b. So I'll get 2 equals -6 plus b. Add my 6 over, I'll get 8. So the equation of my line is y is going to equal 2x plus 8. So we plugged in our point and our slope to find our b, our y-intercept. So our line starts at the point 0.08 and will go up to over 1. All right, next example is a horizontal line that passes through 6, -5. Remember, horizontal lines have a slope of 0. They are also y is equal to a number, because remember, all of our y's are going to be the same because we don't change going up or down. We stay the same, so all our points stack up left to right. So in this case, our equation is going to be y equals, and what is our y equal? -5. You could have plugged in a slope of 0 and got that. If you have a vertical line, remember that's x equals a number, and that slope is undefined, so you can't really plug in a number there. So it's easier to remember that horizontal lines are y equals a number. Your y stack up left to right. And for a vertical line, x equals a number. You don't change left to right, so all your points stack up and down. All right, one last example with slope-intercept form. It gives us 2 points that our line passes through, 5, 2, and 7, 9. So remember, the first thing we have to find is our slope. And to get our slope, remember, it's the change in y. So y2 minus y1 over my change in x, which is x2 minus x1. So I'm going to take my y-coordinate. It's 9 minus 2. Over my x-coordinate, 7 minus 5. In this case, I'm going to get 7 halves. And then I just need to pick a point to plug in. I'm just going to pick 5, 2. So if I plug that into y equals our m times our x plus b, I'll get 2 equals 35 halves. plus b. And if I subtract my 35 halves over, I'll get a negative 31 halves for my b. So the equation of our line is y equals 7 halves x minus 31 halves. Remember to always keep your slope as an improper fraction. If you changed your b to like 15.5 or 15.5, that's okay. But your slope is a ratio, so it has to stay an improper fraction. Because remember, it tells us that our line moves up 7 and over 2 as we travel along the line. All right, so that was slope-intercept form. The other form of line we're going to talk about is point-slope form. So what's nice about point-slope form is we can use any point we're given, not just the y-intercept and the slope of the line. So we're going to still find the slope, and then we're going to plug in one of the points that are on the line, and we're going to write our equation. All right. So we're going to take our y minus our y-coordinate, and we're going to set equal to our slope times x minus an x-coordinate. So here's our first example. We have a slope of negative 3, and we pass through 1, 9. So in slope-intercept form, we would have had to find the y-intercept. But here we just need a slope and a point, which is what we have. So we're going to take y minus our y-coordinate, which is 9. And we're going to set it equal to our slope, negative 3, times x minus our x-coordinate, which is 1. So this is actually an equation of a line. And point-slope form is used a lot when you're finding equations of tangent lines in calculus. And since we're in pre-calculus, this is important that we learn how to use this. You could distribute your negative 3 through and then add your 9 over, and we'll get your equation of your line in slope-intercept form. But in point-slope form, this is okay. All right. Second example in point-slope form, our equation of a line that passes through these 2 points. So the first thing we need to find, as usual, is our slope. So I'm going to take my y2, negative 10, and subtract my y1 of 6, and put it over my x2, 8, minus my x1, negative 2. So I'm going to get negative 16 over an 8 minus negative 2 becomes 8 plus 2, so I get 10. So that if I reduce that, that is a negative 8/5. All right, so I have a slope and I have 2 points, so I can have 2 different equations here. You only need one. I'm going to show you both so that you know how to get both. So let's start with negative 2, 6. So I'm going to take y minus my x-coordinate, or y-coordinate, excuse me, so 6. It's going to equal my slope, negative 8/5, times x minus my x-coordinate. So if I subtract a negative 2, just like up here it became addition, it's going to become addition here. So I'm going to have x plus 2. So that's one answer you can have. Or the other answer you can have, we're going to take y minus our y-coordinate, so negative 10, so it's going to become plus 10. It's going to equal our slope times x minus our x-coordinate, 8. So these are both equations of the same line. If we distributed our negative 8/5 through and added our 6 over, and distribute our negative 8/5 through and subtract our 10 over, we would actually see that they had the same equation in slope-intercept form. So that's why we learned slope-intercept form first, because no matter what point it passes through, it is the same for the whole line. And then point-slope form is helpful when learning, again, tangent lines to graphs. So it's nice that it works at different points, but they also give you different equations at different points. All right, so slope-intercept form is y equals mx plus b. point slope form, y minus y1 equals m times x minus x1. Your worksheet does not specify which one you should use, so you can use either one. So your answer might look different than your friend's, but that's okay, because each problem has multiple answers. And make sure you look on Brightspace to find a copy of this worksheet. If you don't have it, that's under assignments the on the activity feed. You can find what you're supposed to do on the virtual day, which I believe is a quizzes using point slope form, so that you get used to that. And have a great day, Cardinals, and make it count.